Hi friends, good evening to you. AS Online for the Staff Selection Commission Junior Engineer exam के लिए on the name of revision series, we are having the discussion on two simple subjects. One is engineering hydrology, the second one is open channel flow. Both engineering hydrology and open channel flow come under water resources engineering. As far as SSC JE exam is concerned, hydrology is having the average weightage of 4 to 5 questions and open channel flow 1 to 2 questions. In every examination 2 questions must, and sometimes even 3 questions also appeared in the papers of SSC JE in the subject of open channel flow. First we see hydrology, then few questions of discussion on open channel flow. When you see the subject of engineering hydrology, 4 major chapters are important. One is precipitation, second one is evaporation, third one is infiltration. After the losses of evaporation, infiltration, runoff. The basic 4 chapters of engineering hydrology which you have to practice, only these 4 chapters. Under runoff we got one important chapter, hydrographs, how to calculate runoff, infiltration, entry of rainfall water into the subsoil during the time of rainfall, evaporation. Evaporation includes evaporation, transpiration and evapotranspiration. It is the process of disappearance of water in the form of vapor back to atmosphere, either from the water body or from the surface of the leaves of the plants or from the given soil with the given crop. And of course, for all of them the source is the rainfall, which we call it as precipitation. Do remember, hydrology has got 4 major chapters: precipitation, that is input, evaporation and infiltration are the losses, input minus losses is equal to output, that is hydrologic cycle equation. आगे चलेंगे. This is the syllabus. What is the weightage? We will see. Engineering hydrology weightage in 2022, in one paper 5 questions, 3 questions, 6 questions and 1 question. In 2023, 3, 2, 5, 2. Minimum 2 I can say, maximum 6, 2 and 6, average is 4. So we can expect on the average around 4 and around number of questions in engineering hydrology. What type of questions are given? What basics you have to learn to get good marks in engineering hydrology? आगे चलेंगे. We will see one by one question with the fundamental solutions. The area under a hydrograph represents dash. We know pretty well. Intensity of rainfall versus time. Intensity of rainfall versus time is called hydrograph. This is generally of this shape. So its area will give you, as this is in millimeter per hour, rainfall will be in hours. Area will give integral y dx, means I into t, mm per hour into hour, millimeter, that is total depth of rainfall received by the catchment. The total depth of rainfall received by catchment will give you area of the hydrograph. So, area under a hydrograph represents total runoff, not correct, intensity of rainfall, not correct, total precipitation received in the entire period, C is the right answer, total depth of rainfall received in the total time of rainfall is nothing but area of hydrograph. See the second question. Select the option that is appropriate regarding the following two statements labeled assertion and reason. Assertion: the orographic type of precipitation that is caused by moving masses of moist air may get lifted up to higher altitudes due to the presence of mountains as barriers. We know this is the cause for orographic precipitation. When the air comes and hit by mountains, then the lighter mass will move in the upward direction to greater altitudes. There it undergoes adiabatic cooling, condensation leading to the rainfall. Heavier air mass will be moving in the downward direction. So, you see the reason. Statement is correct. Reason: moving masses of moist air are lifted up due to higher altitudes due to the presence of mountains as barriers, and consequently they undergo cooling, condensation and precipitation. He is explaining what will happen after lifting of the air masses. It is not the cause for the lifting of air mass. Consequential effect is giving this as the reason. So, this cannot be the correct reason. Only assertion is correct, reason is false. Means assertion is correct, reason is not correct, option A is correct, assertion is true, but reason is false. Statement A: consequently they undergo cooling and condensation and precipitation. The statement is correct. So, you can say reason is also correct, but they are not correct explanation. So, instead of giving this as the correct answer, both assertion and reason are true. Reason is not the correct explanation of assertion. So, friends, dekh lijiye, you understand that after hitting of the air mass with the mountains, air mass will move in the upward direction followed by adiabatic cooling, condensation, then precipitation. Statement reason is correct, assertion is correct, but reason is not the correct explanation. For this question, C is the right option. C is the right option. Reason is not false. Reason statement is also correct, but it cannot be called as reason. आगे चलेंगे. The precipitation is collected and measured in a rain gauge. The non-recording type rain gauge extensively used in India. Only non-recording type is Simon's rain gauge. Other three, flow type, weighing bucket and tipping bucket, they are recording type rain gauges. Only D is the non-recording type rain gauge. Which of the following is the rain gauge adopted as the standard recording type rain gauge in India according to the IS code 5253? Please do remember, siphon type, that is flow type rain gauge, is the standard rain gauge recommended by IMD, Indian Meteorological Department. Standard recording type rain gauge as recommended by that particular code is natural siphon or flow type rain gauge. The science that deals with the occurrence, circulation and distribution of water on the earth and the earth's atmosphere is known as dash. Water distribution, occurrence, circulation, everything is dealt with in the subject of engineering hydrology. Of all water bodies, how does the water occur? How does it get circulated and recirculated? That is called hydrology subject. It is a good question. Match the following with respect to the types of precipitation. We know there are two types of precipitation. One is liquid precipitation called rainfall. Second one is frozen precipitation, that is nothing but snowfall and other types of precipitations. As you can see, sleet, glaze and hail. Sleet. Sleet is the frozen raindrops of transparent grains that are formed when the rainfall through air at a sub-freezing temperature less than 0 degrees centigrade. 1C is correct. 1C is correct. Glaze. Glaze is the ice coating formation when rain or drizzle comes in contact with the cold object on the ground. Glazing. Even on the grass, we are able to get the glazing of raindrops. So 1C, 2A, obviously 3B, hails and hailstorms, we know pretty well. It is a showery precipitation in the form of irregular pellets or droplets, lumps of ice of size more than, generally we say 6 mm, here has given 8 mm, no problem. So hail is B. 1C, 2A, 3B. See where it is. 1C, 2A, 3B. My dear friends, थोड़ा सा डेफिनेशंस को याद रखना होगा. Precipitation is liquid precipitation, frozen precipitation. Frozen precipitation includes snowfall and other types of precipitation. More than 15 types of frozen precipitation is there. Liquid precipitation is only one, that is rainfall. It is a good question. Informative. Informative means you have to remember the answer. The rainfall observed for 5 successive days in a catchment is 2, 3, 4, 5, 6 centimeters every day. 5 successive days. Compute the direct runoff from the catchment due to this rainfall. The F index of the rain, F index means phi index, that is nothing but infiltration capacity of the soil, is assumed to be 2 centimeter per day. First day, my dear friends, 2 centimeter rainfall, infiltration 2 centimeter, there is no runoff on the first day. Sorry. Out of second day, out of 3 centimeter rainfall per second day, 2 centimeter is infiltration, runoff on the second day will be 1 centimeter. 4 centimeter rainfall, 2 centimeter infiltration, 2 centimeter will be the runoff on third day. 5 centimeter rainfall, 2 centimeter infiltration, 5 minus 2, 3 centimeter is the depth of runoff on the fourth day. Last day, rainfall is 6 centimeter, infiltration is 2 centimeter, so runoff will be input minus losses will give output 6 minus 2, that is 4. 2 minus 2, 0, 3 minus 2, 4 minus 2, 5 minus 2, 6 minus 2. If you add up, total 10 centimeters will be the runoff collected from the catchment on the whole of 5 days. You are going to receive the runoff of how much? 10 centimeter. See where is the 10 centimeter? B is the right answer for the given question. 10 centimeter is the depth of runoff from the catchment in the entire 5-day duration. Select the option that is appropriate regarding the following two statements labeled assertion and reason. A loose permeable sandy soil has higher infiltration capacity than that of a tight clayey soil, that is definitely correct. A soil with poor under drainage has a higher infiltration capacity. Poor under drainage. Sand is having the poor higher under drainage, so sand is having higher infiltration capacity. So, reason is not correct. Statement is correct, reason is not correct. Both assertion is true, but reason is false. B is the right option for the given question. Arrange the various zones of distribution of the soil moisture in the infiltration process. Various zones of distribution of the soil moisture. First, we know it is the wetting zone, A saturation zone, B wetting zone, C transmission zone, D transition zone. First, the water should get transmitted, then it should get transition, then it should get wetting, then it finally will get saturated. CDBA is the correct option for the given question. It is the various zones of distribution of soil moisture. The following statements P and Q are derived on the basis of the precipitation values from the mass curve of a rainfall of self-recording rain gauge given in the table. Identify the correct statement or statements and select the most appropriate one. So, time and cumulative rainfall has been given. Intensity of rainfall during the time interval of 0 to 15 hours, rainfall is 6 mm. 6 mm in 15 minutes, 0 to 15 minutes, 6 millimeters in 15 minutes. 60 to 75, 60 to 75, 30 to 35, 60 to 75, 15 minutes, 5 mm is the rainfall in 15 minutes. So, he said intensity of rainfall during the time interval is more. Yes, P is correct. Q, there is no rainfall during the time interval. At the end of 30 minutes, 15 mm cumulative rainfall. At the end of 45 minutes, same 15 millimeter cumulative rainfall means in that 15 minutes time, catchment area has not received the rainfall. So, there is no rainfall during the time interval of 30 to 45. Q is also correct. Both P and Q are correct. Identify the correct statements as asked. So, both P and Q are correct as per the data given to you. Please see this question. Intensity of rainfall, depth of rainfall by time duration. Similar model, it has appeared on the previous slides also, same model. The rainfall on 5 successive days on a catchment was 2, 6, 9, 5 and 3 centimeters. If the phi index of the storm is taken as 3 centimeter per day, total direct runoff from the catchment will be dash. First day 2 centimeter rainfall, but infiltration 3. So, 2 minus 3 is minus 1. It is not minus 1, runoff cannot be negative. When the intensity of rainfall is less than phi index, runoff is 0 but not negative. So, first day 0 runoff. Second day 6 centimeter rainfall, 3 centimeter is infiltration, 6 minus 3. Third day 9 centimeter rainfall, 3 centimeter infiltration. Fourth day 5 centimeter rainfall, 3 centimeter infiltration. Last day 3, once again 0. When do you have the runoff? When I is more than 5. When do you have 0 runoff? When I value less than or equal to 5. This means runoff is 0. This means runoff will exist. He may ask a question like that also. In which of the following situations a catchment area will receive some runoff? Answer, when I is more than 5. When the intensity of rainfall is more than infiltration index of the catchment, then only we have runoff. When I is less than 5, I is equal 5, runoff will be 0. See, the first day and last day runoff is 0. Your answer 3 plus 6, 9 plus 2, 11 centimeter is the answer. Correct answer for the given question, 11 centimeter is the collective runoff combinedly on 5-day storm on the catchment. याद रखिएगा, when I is more than 5, runoff will exist. When I is less than 5 or equal to 5, runoff will be 0. Runoff will be 0. Please understand this problem. A good model, 2 times it appeared. We have the mega mock test, 26th May 2024, exactly coming Sunday. Please register yourself, attend the examination. You will get some idea about how the paper will be. Mock test means almost similar standard questions we will give in the paper. So, get advantage of writing the mega mock test on the coming Sunday. A watershed having an area of 4 km square is subjected to the rainfall event of 9 centimeter, thereby generating stream flow at the outlet of the watershed for 10 hours. Average stream flow rate at the outlet of the catchment is 5 meter cube per second, occurring for a period of 10 hours. The runoff coefficient will be dash. Watershed having an area of 4 km square is subjected to the rainfall of 9 centimeters. Depth of rainfall into area by time. If you want to calculate the runoff depth is equal to runoff discharge into time divided by catchment area. Runoff discharge into time will give volume, volume by area will give the depth. Rainfall depth we know 9 centimeter. If you get runoff depth, runoff coefficient will be runoff depth divided by rainfall depth. Runoff depth divided by rainfall depth will give runoff coefficient. Discharge is 5 meter cube per second. Runoff is taking place for 10 hours. 10 hours means 10 into 3600. Time, meter cube per second into second meter cube. Area 4 km square, 4 into 10 power 6 meter square. Meter cube by meter square is meters. I want in centimeters, multiply with 100. This is in meter cube per second. एक बार units check करो. It is in hours, this is in seconds. Meter cube में आएगा, divided by meter square में आएगा meters. But rainfall depth is given in centimeter. To get uniformity of units, I am multiplying meter into 100. You will get in centimeters. 1, 2, 3, 4, 5. 10 power 6 इधर 10 बचेगा. 4 will give 9 times. 9 into 5, 45 by 10. You will get 4.5 centimeter. So, what is the runoff coefficient? Runoff depth is 4.5 centimeter. Rainfall depth is 9 centimeter. Runoff depth by rainfall depth will give runoff coefficient. As you know the definition, it is exactly 0.5 friends. You can see B is the right option. How you are calculating runoff coefficient? Runoff depth divided by rainfall depth. How do you get runoff depth? Runoff discharge into time of runoff divided by area of the catchment taken in appropriate units. good model. I am keeping a star mark. Such models once or twice you should practice not to commit any type of mistake. Rainfall depth is given, runoff discharge is given, area is given, time is given. Discharge into time will give volume of runoff. Over the catchment you will get average runoff depth. Average runoff depth by average rainfall depth will give you runoff coefficient K, or some symbol we use, generally we use K symbol. Select the correct option. Runoff is the function of precipitation, intensity, duration and its coverage. The size of the catchment has a definite effect on the runoff. The more the area, the lesser will be the runoff. More the area, lesser will be the runoff. This is the false statement. Runoff is a function of not only precipitation, function of precipitation, intensity, duration and its coverage along with catchment characteristics. Along with. So technically one is correct, two is wrong. One is correct, two is wrong. But if you see, runoff is only the function of, if you say like that, that is wrong. He said runoff is a function. Yes, runoff definitely depends on precipitation. Jada rainfall, more runoff. 5 mm per hour, 8 mm per hour. In the case of 8 mm per hour, more runoff will be developed by the catchment. So because he said a function of, statement 1 is correct, statement 2 is absolutely wrong. Therefore 1 is true, 2 is false. My their meanings in the second column. Surface runoff, the runoff that is following on the ground, above the ground, unconfined flow of water over the ground surface, A2 is correct. Interflow, base flow. Interflow, delayed subsurface flow at a shallow depth. Base flow, portion of the water that moves laterally in the upper part of the soil. Delayed subsurface flow at shallow depth. Base flow C1 is correct. A2, C1, interflow, portion of the water that moves laterally in the upper part of the soil. So B3, A2, C1. So this is my correct choice. You should not get confused between interflow and base flow. Interflow, portion of the water that moves laterally in the upper part of the soil. Base flow, delayed subsurface flow. Prompt subsurface flow will become a part of direct runoff. So A2, B3, C1 is the correct answer. The ratio of total length of the streams of all orders within a basin to its area. Total length of the streams of all orders by catchment area, that is called drainage density. DD is the symbol. Drainage density is the symbol, is the formula for total length of the streams per unit area of the catchment. When the precipitation of the storm reaches the ground, it must fill up a basin which is lower than its surroundings before it can flow over the surface. The volume of the water trapped in the basin which is lower than its surroundings is called dash. So, rainfall is falling like this, catchment area is like this, then the water starts flowing on the ground. This water entrapped with its elevation lower than the surroundings, it is the surrounding elevation. This is at particular location. This is called the volume of the water stored. As you know pretty well, it is one of the initial losses. Interception and depression storage, these two are initial losses of the given catchment. What is depression storage? When the rainfall is received by a geographical or a topographical depression. What is meant by depression? A ditch which is at lower elevation compared to the level of the surroundings, that is called a ditch or a depression. Water accumulated in the depression is called depression storage. Dear friends, B is the right option. Straight away definition is given. It is one of the initial losses. Two types of initial losses will be there. One is the interception, the rainfall that is stopped on the way, the rainfall stopped by the terrace of the building, the rainfall stopped by a man walking on the road. So, answer B is the answer for this question. Other things are, some are having some sense, some are not having any sense. Let us not bother. See the technical definition. Identify the Dickens formula used for the estimation of the peak rate of discharge, QP, peak discharge, during the flood from a given catchment area. Q peak is equal to CD into area power 3 by 4. CD into A power 3 by 4. Dickens formula is applicable for the catchment's estimation of empirical formula for runoff. Select the correct statement with regard to the following two statements H1 and H2 pertaining to the hydrograph of a storm in the catchment. Rising limb of the hydrograph depends on catchment characteristics only. This is absolutely false. Rising limb 60% depends on rainfall, 60 to 70%, 30 to 40% depends on catchment characteristics. More weightage is given for the intensity of rainfall and duration of rainfall only. The recession limb of the hydrograph depends on storm characteristics and catchment. This is also not correct. Why? Because the recession limb, falling limb, depends only on catchment characteristics. H1 is wrong, H2 is wrong, so C is the right option. Both H1, H2 are false. Both H1, H2 are false. Identify the method that is not used for the computation of average rainfall in a catchment having a number of stations. We know to calculate the average rainfall there are three methods: arithmetic mean method, Thesian polygon method, iso-Heitel method. Arithmetic mean method, Thesian polygon method, iso-Heitel method. The method that is not used, so hydrograph method is not used. So correct answer D is the correct answer. ABC are the methods used to calculate average rainfall. He has asked not used, so D is the one which is not used. This method is not used to calculate P bar. These three methods are used to calculate average depth of rainfall. Average depth of rainfall. As per the Dickens formula, QP is equal C into m to the power of 3 by 4 for the calculation of peak drainage discharge. The term m indicates what? I told just now, C into A power 3 by 4, A is the catchment area in square kilometers. This is the right answer. Dickens formula, QP is equal C into A power 3 by 4. QP in meter cube per second, A in square kilometers, to calculate the runoff discharge from the catchments. The flood absorption capacity of a reservoir. Flood absorption capacity of a reservoir. It is the same as the dead storage. Wrong. Some percentage of the storage capacity of the dam is no. The water it can absorb through the seepage is not correct. The storage between FSL and minimum water level, this is the correct answer. D is the correct option for the given question. Highest momentary peak discharge at the respective point of observation in the river flow, which is equaled or exceeded once every year, is known as dash. It is called annual flood. Define annual flood. It is the highest momentary peak discharge at the respective point of observation, which is equaled or exceeded once every year. That is called annual flood. These are the questions on hydrology. As far as the open channel flow is considered, in syllabus they have given only flow through open channels. Three areas are important: geometrical cross sections of the open channels, critical flow condition, specific energy, specific force, most economical section. We know what is meant by most economical section. For the given area, when the discharge is maximum, when the velocity is maximum, when the wetted perimeter is minimum, you will get the most economical section. Also, we should know about critical flow in open channels. Critical flow is the flow when the specific energy at the given cross section is minimum. Remember these two. Section is said to be most economical when for the given area discharge is maximum, hence velocity is maximum, hence R is maximum, hence P is minimum. You have to remember the basic condition: minimum wetted perimeter. Minimum wetted perimeter. For the given area, if the discharge is maximum, section is most economical. Discharge is area into velocity, area into 1 by n into r power 2 by 3 into s naught to the power of 1 by 2. When q is maximum, velocity is maximum, so r is maximum, so p is minimum. One more definition आपको याद रखना होगा. What is meant by critical flow? When the specific energy is minimum. Critical flow section is different. Most economical section is different. Let us see what questions are given. In an open channel flow, for best efficiency of a rectangular section channel, ratio of bottom width to depth will be dash. For best efficiency means most economical. For most economical section, B is equal to y, R is equal to y by 2, B is equal to y. So area will be 2y square. Wetted perimeter is for a rectangular section B plus 2y, 2y plus 2y, that is 4y. A by P, R will be y by 2. So these conditions आपको याद रखना होगा for most economical rectangular section. B is the bed width, y is the depth of the flow, and R hydraulic radius or hydraulic mean depth. क्या दिया? In a rectangular section, bottom width to depth of the flow B by y, B by y is 2. 2 is the right answer for the given question. For obtaining the most economical trapezoidal channel with the depth of the flow 3 meters, what is the hydraulic radius? R is equal to y by 2 is the condition for most efficient trapezoidal channel. If you take a regular hexagon, semi-regular hexagon, most economical section of a trapezoidal channel will be the semi-regular hexagon. That's why R is equal simply y by 2, y is 3 meters. What is the hydraulic mean radius? 3 by 2. 3 by 2, correct answer is 1.5 meters is the right option. He may ask you which of the following is the condition for most economical trapezoidal section. Top width is equal to sum of the sides. R is equal to y by 2. Shape of the most economical trapezoidal section, semi-regular hexagon. Specific energy of the flowing water through a rectangular channel of width 5 meters when the discharge is 10 cubic and the depth of the water is 2 meter is dash. Width is rectangular channel, width is 5 meters, depth is 2 meters. Area will be 10 meters square. Discharge will be 10 meter cube per second. Velocity will be Q by A, that is 1 meter per second. Has asked what is the specific energy. Recall the formula for specific energy is very important. Sum of the potential and kinetic energies. Potential energy per unit weight, of course we know definition of specific energy, energy per unit weight of the water. Y plus V square by 2G is the formula. Y will be 2 meters, V will be 1 divided by nearly 20.05, nearly 2.05 meters will be the answer. 2.05 meters is the answer for the problem. Please remember, here you should remember 2 points. Formula for specific energy, E is equal to energy per unit weight of the water. Potential energy mgy by mgy. Kinetic energy half mv square by mg v square by 2g. So what is the mathematical formula we are having for specific energy of the flow in a given open channel? Y plus v square by 2g is the formula for specific energy of the flow. Substitute the given data, you will get the value of specific energy. A very simple question but standard question. Specific energy का definition याद रखना होगा, rectangular channel का cross sectional details याद रखना होगा. Substitute कर लिया तो you are able to get the correct answer, my dear friends. Consider the given statements with respect to most economical sections of a rectangular channel. Select the correct option. Discharge shall be maximum, correct. Wetted perimeter should be minimum, correct. Both the statements are true. I told just now. Q is maximum, P is minimum for the most economical section. Q is maximum, P is minimum. That is what I was asked now. Discharge is maximum, wetted is not welted, wetted, minimum. So, both statements are true, my dear friends. What will be the carrying capacity of a horizontal rectangular channel 4 meters wide conveying a discharge of 1 cubic per meter width of the channel? Small q will be 1 meter cube per second per meter and width is 4 meters. What is the carrying capacity Q? Q is equal to Q into B. What will be the carrying capacity of a horizontal rectangular channel? 1 into 4, that is 4 cubic. Simplest question of the entire paper. Simple formula. What is the formula for unit discharge? Unit discharge is discharge per unit bed width. So, what is the formula for discharge? Unit discharge into bed width 1 into 4. क्या वो आंसर? 4 meter cube per second. That is the answer for the question. A rectangular channel of bed width 2 meter is to be laid in a bed slope of 1 in 1000. Find the hydraulic radius of the canal cross section for the maximum discharge condition. Hydraulic radius of the maximum discharge. When the discharge is maximum, wetted perimeter is minimum, means B is equal to Y. Bed width is 2 meters. He has asked what is the hydraulic radius. If a bed width is 2 meters, Y will be B by 2. Bed width is 2 meters, so it is 1 meter. Has asked hydraulic radius R. R is equal to Y by 2, 1 by 2. Answer for the problem is 0.5 meters is the right option. See how much simple questions they are asking on open channel flow. Only two are important: geometrical properties, most economical section and critical flow section. Please practice and get advantage, get selected for SSC JE, one of the wonderful jobs. What is the rate of flow in a rectangular channel 4 meters wide and 2 meters depth with a bed slope of 1 in 1000 when it is running full with the Chegis constant 50? It is also a straight away question. Rate of flow Q, area into velocity, because Chegis constant is given, A into C into root of Rs. A is By, C, R is area By by wetted perimeter B plus 2y whole multiply with S. B bed width 4 meters, depth 2 meters, C 50, B 4 into 2, 4 plus 4, 4 into 2 by 4 plus 4 into S, 1 in 1000, 1 by 900. It is 8, 8 cancels, 4 into 2, 8 into 50 by 30, 8 into 50 by 30, 0, 0 gets cancelled, 40 by 3, 13.33, it is 40 by 3, 13.33 meter cube per second is the right answer for the given question. These are some of the model questions given in hydrology and open channel flow, and go through the basics once again and practice all the PYQs of the last at least 5-6 years, and I wish you good luck. Thank you for your kind concern and kind hearing of this particular session. Thank you.